right. Yesterday I worked on making sure that when I'm writing tuples to the database files, a single record won't span a 4K boundary. That has broken the iterator that reads back, basically the table scanner iterator. And so what I want to work on today, the goal is in the next hour to fix that so that it can tolerate sort of some gaps and tuples near 4K boundaries. So that's what I'll be up to. Let me set a timer. Oh, I already had a timer set. Let's set the timer. Okay, cool. And make it happen. Cool. So I'll be looking at relation, and what this is going to do, you know what? Actually, I think the implementation is right here. Yeah, because when we have this sort of static method that wraps the constructor, and in there we have this enumerator block, which, yep, every time you call .next, it's going to run this code until it gets to this line, and then it's going to stop, yield execution back to the caller, and then, but it holds state. Holds the state of where it's at. So what we want to do is basically in here make sure that, like, if you get to a boundary, or if you see a zero length tuple, just like don't freak out. And actually, I guess let's see this failing so that we know that it's actually working. Some test-driven development. So let's make a new script, and let's, we'll just make this the whole thing. Cool. Let's require relation. Let's require relative relation. Cool. And then we're going to get, what did I call this? Updated movies equals relation dot from new DB file. We're going to pass it updated movies dot DB. And then I think what we're going to do is basically just iterate. Let's just iterate through. So we'll say updated movies dot data dot each do, and this will be our tuple. And let's just put what does this yield? It yields a tuple. And a tuple will be what will a tuple be? An array. And we're just packing stuff into the array. The schema for this is ID and then title, so let's do puts tuple last. So last value, this should be the movie title. And let's just do that, and we'll put EOF at the end. So this will help us know if we actually got to the end. Okay, cool. Let's save this in scripts, and we'll say relation scanner.rb. Cool. And yeah, value of having it in a script is that we can call it here, slap the output somewhere. So let's do Ruby relation scanner RB. Pipe that to the file called out.txt. I don't have one of those right now. Cool. No such file or directory. Scripts. Negative length. Cool. I think this is us failing. Okay, cool. Yep. So if I remember correctly from yesterday, Blue... What was the name of that movie? Well, maybe we'll recognize it. Man of the Year. No, that wasn't it. But, okay. So let's look in the updated movies. Open with Text Editor and Man of the Year. Neon Bible. That was the one from yesterday, not Blue. Yeah, this is at the 4K. This is the first record at the 4K boundary. This was the record that wouldn't fit. Man of the Year is the one right before that. So yeah, basically we get to here and we freak out. So we don't reach the end of file. So there's our failing spec, essentially. All right, and let's fix it. Okay, so what is the algorithm here? We open the file, we get the header length, we rewind, we grab the header buffer by reading the header length, and then we load the header here so we have some information, and we're going to spin up a new enumerator. That enumerator is going to hold a position in the file, and it's going to loop. It's going to, yeah, the position may have changed from underneath us. We should probably be good citizens and like get the position, save the position, set the position, but we won't. We'll wait until this is a really nasty bug and then we'll fix that. We get the position, we get some an array to put the values in, and then for each field that we find in the table header, and that is a hash with something and then some metadata about it. We get the name. Oh, this is the name of the field. Okay, and that's some metadata. If basically the name of the field type is a little confusing. If it's a string, yeah, blah, 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 do all of this. So we get the content length from the content length of the record. Interesting. Okay, and the value length is the content length minus those 2 bytes that we just read. The value, oh, we do this snazzy thing so that we can kind of do this splat destructuring thing. Read the value length and unpack it, and then position, we increment the position by the content length. We increment the position like that we're tracking in the block by the content length. Okay, cool. So here we do have some information about length, which is great. The other condition here is that else the value we read, so the metadata knows the size based on the data type. So we read that many bytes and we unpack that data based on the template. So this would be like L for long, S for short, like this. We increment size and then we're on our way. Okay, cool. So all that to say that if we're looking at a record on disk, let's open this up again. Eventually I'll remember how to do that. Yeah, like here's a record where a record starts. So here's one field. This is an ID. It's 2 bytes long. The value is 1. And then we increment, and now we see this field, which we have a length because it's variable length, and so we know, like, all right, here's where it's going to end. Okay, and if we go back to Neon Bible, if we finish up with the Man of the Year record, our final position is going to be here, and we're going to so this happens in order because we expect these to be encoded in the same order. First ID, in this case, first ID, then string. So anyway, the value of so we're going to read these first 2 bytes because the metadata says that this should just be a 2-byte integer. So it's going to assume that we have a record with the ID equal to 0, and then it's going to go here and read maybe here, say read 2, unpack that. It's going to be a 0 length. It's going to be 0 minus 2. For value length, we're going to try to read -2 bytes, and that's where our error came from. Okay, cool. So what we can do here is, so we could do something really simple. Where my mind goes is a tuple header. So at the beginning of each of these records, so basically from here to here, this is a record, from here to here, this is a record, from here to here, this is a record. We basically, right before these 2 ID bits, we could put a content length there. It's an iteration. I'm thinking down the line and how we might use it to skip over records. Again, kind of holding in mind that eventually we'll tackle indexes and looking up things that way. If we're in a table scan situation, because we don't have an index, and we're, let's say, sorting or What's the other? Like doing a range query or something like that. And we're reading values. We're going to have to read the record anyway to get to the thing that we want to, apply a predicate to. So I don't see a huge use for this header, though we do know that storing null values, this data set doesn't have null values, which is nice, but eventually you need to get there. So you could do something like select blah, 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 where blah, blah, blah is not null. That we can't do here, which is a bummer. So maybe we just throw a tuple header in there, which just has a tuple length, and just kind of let that be for now. So maybe, let's implement that first. So we'll implement some more changes to the database file so that we can read it back. The alternative, which maybe just to say it out loud, is that we could just read to the end of the page and be like, oh, are these all null? Then this must be done. We must be finished with this. That seems like a lot of reading and seeking and skipping, and that's I/O that we don't have to do. One I/O, we should be able to determine in one I/O if we're either done or if there's more to grab. And we're kind of relying on just the end of file, because at the end of the file, which I don't know if we can easily get there, it's kind of funky sometimes. This would we would get an end of file error. Which is fine. Okay, cool. So let's go back to our insert tuple. Okay, cool. We were just here yesterday. It should be familiar. And it should be a pretty simple update here. If it's on one screen, great. So in our buffer, what do we do here? We pack the fields into the buffer. And then what we want to do is get so at this point we have all of the information that we're going to need. And then at this point, let's say calculate tuple size, and then let's do add tuple header, and then write to disk. So these are kind of our to-dos, these two things. Okay, cool. So at this point we have a what do we have in here? Can we easily get, so can you put data types over here and remind myself, size, sweet. So there's fixed length sizes for integers, floats, and timestamps. For strings, that depends on content. Okay. I'm wondering if we could just calculate size here. Yeah, let's just do that. Let's do tuple size equals 0. And then let's say tuple size plus equals content length. So we've already calculated that right here. And then let's do a similar thing Okay, cool. Let's do a similar thing here. Content length equals metadata size. And this is all in bytes. That's the, like, yeah, that's the unit we use. Cool. All right, so we've got our size there, so we really don't need to calculate tuple size. We know what it is. So let's add a tuple header. So let's do buffer. Is it shift or unshift? IRB 1, 2, 3, shift 4, unshift, unshift. Buffer dot unshift, and then let's do tuple size, and our Pomodoro is going off. That was a good iteration. I need to change the interface on this thing. I don't want to snooze or play. I don't want to take a break. Just want to do it. There's a bug there. Don't know what it is. Okay, let's go back to here. Cool. So we add a size which, let's say that the tuple header is going to be 16 bits. So I'm going to hold off on some math about how that would affect field size and all of that, because all of that is a concern, but yeah, let's just let it be for now. It's a toy at this point, anyway. So I'm going to initialize tuple sizes to size consumes to, well, hold up. Yeah. Size occupies 2 bytes. Cool. So we're going to put the tuple size at the front of the, well, essentially this is the header. We're going to put the header at the front of the line. So it's going to be the first thing in the tuple record on disk. And then we're going to do, and in fact, we could just make our template string start with a S for short. First element is a 16-bit tuple header for size. Cool. So we kind of initialize it that way. And we'll add size to the buffer once we have it. Let's see if it works. Okay. So we haven't like explicitly dealt with like the 0 length case, but because, well, we kind of have, because we're just packing in null bytes, which are zeros. So we'll read that next tuple length as a 0 length tuple and need to deal with that in the scanning code, but we'll get there. So let's see this working. Let's get out of here. We've got this going on. Let's go to our load movies script and let's do updated movies with tuple headers. That's going to be our relation name. so this makes a little bit more sense. We'll just do this. We'll just do this. Yeah, cool. This won't need to be like this so that we're just not inserting the old thing. Cool, and this is going to invoke the code that we just changed. Alright, let's see if it breaks. Cool. Ruby.scripts/load movies rb out.txt. I don't know if this is going to truncate the thing, but let's just delete it anyway. Move to trash. Okay, cool. Okay. Updated movies with tuple headers. Let's see. Open with hex editor. Cool. We see that this is a little longer, which is cool. And we've got this. It shows 22. So let's see if it's actually. Oh, you know what? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, okay, 16, 17, 18, 19, 20, 21, 22. Great. I expected that to be too short, like 2 bytes short, and it wasn't. Why not? I mean, great, but oh, because we initialized the tuple size with 2. Perfect. Okay, cool. Well, that seems great. So we've done that, and then let's try reading it back. Let's also look at the, I don't know why this would have changed, but yeah, so we still do see that there's something here. Now this changed the game. Jupiter's wife is kind of the one that we want to be looking at. Let me just capture this so I remember that name. Silence of the Palace. Okay, cool. That's the last one in the page. Awesome. We'll close that. Close this down. Okay, let's do a April 29, 23 branch, and let's add these changes. Cool. And I won't commit the notes yet because we're not done with those. And let's say add tuple header to database files on insert. Okay, cool. We will commit that. All right, and then let's go back up to where we create this iterator. I haven't made many changes here. Let's just like kind of fork this like I did before. I'll say movies. What was this called? Updated movies with tuple headers. Headers not db. We'll take this to do out because consider page. So that would have been another approach that apparently was on my mind yesterday that I didn't even think about this morning. And that would be to have page headers to say, like, this is how many things are on this page. how many records are on this page. The thing that kind of weirds me out with that is if you look at this little layout thing that I did yesterday, is that our first page has a header involved. And so this design could change, at which point maybe that makes sense. But this would essentially like have a little, like somewhere in here, like with this special like first page case where there's a header involved, we'd have to figure out how to do that. And that seems like it adds a little complexity to me. I think we also know that like to support null values, a bit array at the beginning of a tuple, in the tuple header, indicating like which nullable fields are null, is something that seems like a direction we'll want to go. So anyway, this tuple header doesn't seem like a bad iteration. So I think I'm happy with what we chose here. Cool. I'm going to get rid of that since we kind of know we're in the middle of it right now. All right. So what we can do is let's, at the beginning of the loop, before we initialize, well, it'll be garbage collected. Let's get tuple size equals file.read2. So we're going to do essentially this. Tuple size. Read to unpack that, and we're going to say, because we might iterate right now, we're going to say position plus equals 2. And then we're going to say next if tuple size 0. I think that's right. IRB 0. Right. Okay, cool. Alrighty. But I think, geez, that should do it, because we'll get to those null bytes and we'll just kind of iterate through this thing. Yeah, we'll just jump back to the top, jump back to the top, jump back to the top. Position equals position, tuple equals, let's do this only if we know there's a tuple. Cool, let's try it. We will have incremented the file position, like the attribute on the file object here, by having consumed things with read. And we'll, our own like local tracking will increment that so that if we do a next, we'll remember that we have read a null record, or a null byte, I guess it's not a null record. And then when we get down here, we will have read this, so the file's position will be where it needs to be to then, like, read the actual content of the tuple based on the fields, so it working the exact same way. Yeah, okay, cool. So let's try this. So we'll do exit. Let's get rid of out.txt. Anyway. so that must be putzing something. Let's fix that just really quick. Not coming from there. Is it not? Puts definitions. This is load the header. Yeah. I'll get rid of that. No results. Okay, cool. Sweet. Let's get back to what we were actually just working on here, which is the from new. Okay, let's get our scripts. I will say, yeah, load. Yeah, from new. And we don't want to do updated movies. We want to do, let's just grab this because this has the names. Copy, paste. Relation. Cool. Okay. Yeah, let's see this working. Ruby /scripts relation scanner RB no args, put it to out.txt. Okay, cool. Undefined method unpack for nil. Okay, let's see what our output says. Oh, interesting. Unpack for nil. Ooh, yeah, that's, ooh. Things got off the rails. Did they get off the rails at the boundary that we might expect they did? Indeed. Here we are. Okay, quick change of scenery. So it looks like, yeah, somehow we kind of got tripped up here. And it looks like, so let's open this with the hex editor. And just see like how wide this null byte is. Let's do Jupiter's wife. And it looks like we've got OA 10, which I think is space. Let's see if this, no, not space. Space is 20. We've got OA, which is Yeah, so anyway, we've got some, it doesn't look particularly, let's see, duplicate. Yeah, I guess I'm thinking, how are we going to diagnose what's going on here? This could either be like, yeah, well, how wide are these? These are just characters. Wouldn't we just assume that these are, they were just like off by 2 bytes? Or not off by like 1 16-byte or 16-bit value? Let's operate that assumption until proven wrong. So in our how could we let's do this. Let's put null byte detected at position. Let's do print. Null byte detected at a certain position. Space, and then let's put incremented to position. Okay, cool. Let's try that. That way we can kind of see where this file reader is by inspecting the database file in the hex editor. Let's just get a reading on that. So let's get out of here, move to trash. This is here. We're just putting some new stuff, and so I want to run the exact same script. Cool. So that might be a clue. Tuple size, if the tuple size is 0, increment the position by 2. But I think we still want to increment the position by 2, even out here. Well, this would be the behavior that we just had before I refactored this just now. Because you would, that position is being incremented outside of like next if tuple size is 0. So this is like unconditional. I just want to do it here so that I get some output about what's actually happening. Okay, cool. Let's do this. Let's try this again. This thing gets really weird. Okay, same thing. All right. So nice. Okay, cool. Null byte detected, because that's going to read 2. We don't want it to read 2. Why would we want it to read 2? We want it to read 1. We want this to read, I think it's C for character. Ruby array pack. Yes, we want to read an 8-bit unsigned character, which is going to be an int. Sweet. All right. And then we're going to do this, and then we're going to do this, and then life is going to be good. So that the problem was there was an odd number of null bytes at the end of the page, and for whatever reason, I thought we needed to read. Ooh. Well, that's not great, because the size is 2. Huh. Yeah, that's going to be a problem. Okay, what if instead of size, All right, think through these out loud. We could, instead of a tuple size and the tuple header, we could just have like a single character that's like set to 1 or something. That means like, hey, there's something here. And then if you see a 0, that means, well, there's nothing there. That's an even smaller increment for like a tuple header. But it's something. Another thing is that at the end of a page for like that last tuple, we could just put like some sort of special value that means like end of tuple. Tough part there is that like, what would it be? Yeah, as far as a small increment goes, I think that the maybe just setting it to 1 would work. Okay, let's try to get that working. Man, this is really just about little increments. Okay. Yeah, because how else would we know? Let's just step through this. Think about it. Open with the hex editor. I get to Jupiter's wife. Yeah, so I've read here, I'm at this position. I read these 2. Well, let's say I read 1. It's null. Null, 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 null. I get here, and it just happens that this is like the high order byte, which no guarantee. What if the endianness was reversed and I read this first? So that doesn't really work. So yeah, if I just make this 1 byte long, so the tuple will start with, yeah, a byte set to 1 versus a byte set to 0. That'll be our header, really low fidelity. Yeah, and there's probably more to work out here. So, okay, let's try that, because otherwise, yeah, we end up reading here, and then we're getting thrown off. Yeah, because we're reading this and then reading a length, and that's getting all sorts of messed up. Okay, cool. You live and you learn. So back over in our insert code. Null light detected deposition. So this is going to be our reader code where we're just reading 1. Yeah. Let's actually see if it works. No, I don't want to. We just know that it won't. Cool, so on insert, let's change this to a C. Let's change this to a 1. We're not dealing with tuple size. First element is a 1 byte header. Buffer equals 1. Tuple tuple, and then we don't need to track tuple size. So I'll get rid of this. I'll get rid of this. Well, you know what? We don't have a reason for tuple size at this point, so maybe debating maybe just leave it in and then just add the byte up front. Yeah, let's leave it. Okay, so let's get back to this. We'll say I'll say header occupies 1 byte, size occupies 2 bytes. Our template string is a C and then a S for 2 bytes. Is that right? What was the change I just made here? One from S. Yeah, cool. Okay. So I'm putting an 8-bit 1 byte value in front of the size, which was a short, which is S. And actually I need to write this 3. And then I put the tuple header right in there already. Okay, cool. There we are. So this might just work then. Add tuple size, because we already added the tuple header technically. Unshift tuple size. So that's not right. So let's do this. Add tuple header. So we're going to say header equals 1 tuple size. And then we're going to say, can you do prepend? That's better. Okay, cool. So buffer does this have it in place? A equals 1, 2, 3. A dot prepend splat 6, 5. A. Yeah, it does happen. Okay, so instead of unshift, we're going to do prepend. And then we're going to do splat header. So our header has a byte, a byte that says there's something here. And it has a size, which is 2. We're going to prepend those. Those have been accounted for here. And in terms of size, buffer is going to be empty. We'll prepend those here. Okay, cool. Let's see this working. Okay, cool. Let's exit. Let's do, let's go back here. Let's remove this guy. Let's get out of here. Updated movies. Okay, cool. And then we want to do our load movies, updated movies with tuple headers, yada, yada, yada. It's going to use our new insert code. Cool, so let's do ruby./scripts /load movies rb goes off without a hitch. Okay, cool. Yeah, so let's see this in action. Let's just do a spot check. The hex editor. Okay, cool. So Toy Story now has byte that's set to 1. It's got this, which is set to 23. If I remember, it was 22 before. So here's 16, 17, 18, 19, 20, 21, 22, 23. Lovely. Let's just spot check our boundary. And it looks like, cool, we do have some null bytes. Oh, these just happen to be ASCII codes. Okay, cool. So flirting with disaster is at the boundary here. So we'll be searching for flirting. Okay, cool. So there's that. And then when we read it back, so we change that here. And then when we read it back, we're going to do something a little different here. We're going to say that let's say read tuple header. We're going to say present size equals read 3 unpack CS. If tuple, if not tuple present, this can be 1 or 0. Print null byte detected at position. We'll increment position by 1. We'll put that we incremented it and we'll go next. Otherwise, we'll increment the position by 3 because we just read 3 bytes. And then we'll continue with this. Let's give it a shot. Ruby./scripts relation scanner.rb out.txt. That still doesn't look good. Okay, cool. Let's see what happened. Flirting. Okay, yeah, it looks like we just didn't get there. Star maker. Is that what was at the very end? Open with hex editor. Star maker. Yeah. So somehow we got here where we're reading -2, which is likely we got here. So let's wait. What? We are using our new one, right? Relation scanner. New, yes. Curiously, we don't see any output about like, hey, we did the thing. Here we are in an hour. We're so close. Okay. What could we do here to get some feedback? Puts tuple header present doesn't. Puts at at position, tuple header, present, size, if is this not evaluating to what I think it's going to evaluate to? We'll see. Just confirm that, like right here, yeah, this byte is 1, so that should evaluate to true. True. Okay, let's see what this output gives us. We're just iterating. Let's close this. Okay. Same thing, makes sense. All right, at 128, present 1, Go to the bottom of the file. Tuple header, present, 0. Size, 0. 0 dot present, true. Wait. Okay. Let's go back to relation. Let's make this a little more explicit. If tuple present dot 0, give that a shot. Undefined method, unpack for no class. New error, great. Flirting. Sweet, okay, yeah, looks like this went well. So we detected a bunch of null bytes. And even when we saw sizes, this is just junk data. And then we're at 4096. We see that we're present. Okay, cool. And then where are we at here? Innocence. So let's take a look at innocence. That might be our entire table, in which case we just won. Open with hex editor. Find innocence. The age of innocence. Loss of innocence. What is this? Innocence 2014. Let's actually just search for that. Innocence 2014. One result all the way at the bottom. Fantastic. Okay, undefined method unpack for nil class. So we can then do this unpack. So let's do try. Not try catch, begin, rescue, Let's give this another shot here. Lovely. So let's do this. Move this to trash. Ignore this issue. Let's get rid of our debugging. Cool. We're still printing in our relation scanner though, which is fine. Let's do this again. Boom. Let's look at out.txt, and we've just got a bunch of movie titles. A bunch of movie titles. Go all the way down to the end, and we put EOF at the end. We've done it. Cool. All right, so our goal, modify the relation scan iterator code, deal with data gaps and page boundaries, is accomplished. We just saw that happen. In order to do that, we fiddled quite a bit with what a tuple header should look like. And in this iteration, add a tuple header that includes a non-null byte to indicate that a tuple is present. And we also added size because that was a failed experiment, and maybe it'll prove helpful. I don't know.